Okay, here we are. This is a video tutorial for the River Meander Migration Modeling, and this is video tutorial number 3. It's entitled Choosing the Centerlines for Calibration. So in this tutorial we're going to launch into the process of calibrating a model. Calibrating is probably the most important thing you do in preparing a model you're going to use for predicting something in the future. And you need to have confidence that your model will simulate reasonable predictions, and in order to gain that confidence we calibrate the model. Okay. Before we launch into actually showing you how to choose centerlines as the first step of calibrating, I want to make some important comments on models. Lay this out right at the beginning. I always say that it's important to remember that a model doesn't predict what will happen. The value of a model is it helps you think about what might happen. Okay, that warrants repeating. A model doesn't predict what will happen. It helps you think about what will happen. The thinking's the important part. Model gives you information, but it should stimulate questions and consideration of many things. Questions come up like, does this answer seem reasonable? Is it doing what I expect it would? If not, why? Anyway, the questions are endless. As a very good modeler friend of mine says, all models are wrong. Some are useful. Okay, I put it out there. With these caveats in mind, we still want to always do the best we can in setting up a model so that it will simulate the future to the very best of our ability. Okay, calibration consists of the process of taking some past period of river migration for which we have existing data. In other words, you know what it actually did. And then if you try and make the model match what happened in the past. You adjust the parameters in the model, you adjust the erosion coefficients and other things in order to make it work for that past situation. Then you take those adjustments and things that you've created that make it work, and you apply it to the future forecasting. Just a word about this, forecasting. Forecasting, simulating, predicting, modeling, these are all interchangeable for me. It's the same thing. Okay. Let's get down to it. There are many ways to go about calibrating this Meander migration model, and I don't have a formula about how to go about it. Each modeling job seems to require a slightly different approach. So I'll be doing a number of tutorials on calibration, of which this is the very first. Well, the first thing we do is we start with defining what area we're interested in. Now, let me go back. This is the bend that I'm interested in on the Sacramento River, again at the Ord Ferry Reach. And it exists in this long reach. So when we choose an area of interest, now some area of interest, sometimes we might be interested in the whole thing and modeling the whole thing. In this case I'm trying to simplify, and we'll look at this single bend. Do note that even when you're modeling a single bend, it's always critical to model upstream of your area of interest at least 2 full bends, and that's a bare minimum. It's better to have a few bends, and as you will see, I'm going to be modeling this entire reach. So I'm modeling the whole thing, but I'm calibrating it for this area. Okay? An important step always is choosing the area of interest, which we just did, and defining the goal of the model. You'll be doing it different ways. You'll be calibrating it in different ways according to the goals. Maybe you've been asked to consider how dynamic a bin is going to be in the future. Maybe you want to quantify the vegetation that's going to develop on a newly created floodplain over an entire reach of river, like the reach that I showed you. Maybe you want to evaluate risk of maybe a house that's close to the bank. And maybe you want to know what the implications are downstream of some kind of management action upstream. So all of those might require a different approach. Those would be goals. Now, my particular goal, a little bit unique in this situation, is to introduce you to using a very simple way to develop an erosion grid that's built in the iRIC platform. So I'm going to make my calibration fairly simplistic because my goal is to show you how to use the tools. Now, before beginning to set up iRIC or work in iRIC at all, number 4 here is we want to consider the influences on migration. Sounds simple, but this is a very tall order, and it's one at which you're just going to have to do your best with the resources you have. In a minute, I'm going to describe at least this situation and the information that I have on what influences migration here. Okay? First of all, take a look at the list here, and then I'm going to repeat that list while I show you the data that I have. So you always have to ask yourself, what kind of data do you have? The history of migration. If you can, look at historical data sets. These days, those are mostly digital. And ask yourself, what has the channel done in the past? Number 3 here is constraints. What could be limiting the migration? Well, riprap and levees are obvious and are big players, but there's also geologic constraints, number 4. And sometimes geologic maps are helpful in other ways. Vegetation. Now, the best example I have of why vegetation would be important is that, this is an example on the Sacramento River at least, the Sacramento River migrates about twice as fast through agriculturally cleared land as it does riparian forest. That would be helpful to know when you're calibrating. And finally, the flow history or flow record. In my particular case, I happen to know that a dam was installed that significantly altered the flow regime. So you need to know things like that. Okay. What are the particular things that influence the migration of my reach? Doing this could take you days. And or if you have a lot of data, you can spend a long time at it. Or you may just use Google Earth for as good a record as you can get. So if you have to spend some time to figure out what you can get your hands on. I'm lucky to have lots of data. And I'm going to show you some of that data now. Okay. First, I've showed you a couple of times, that's the entire reach that I will be modeling. And this is the area that I'm concerned about for calibration. So I'm lucky to have a history of migration there, starting in location of the river in 1904, 1938. You see this bend is starting to move in that direction. 1942, a little odd happened there. 1952, starts to move downstream. 66, 1976, you can see this purple moving in that direction. Now remember, this is 2015, red. 1987, it reaches to that point, and in 1997 it doesn't go beyond it. And in fact, in 2004, it doesn't go beyond that. Okay, so it really hasn't moved much in the 30 years since 1987. Now, we happen to have the good fortune of having a file that shows the riprap that's been installed on the river. And if we take a look, if I can, you'll notice that that riprap was installed in 1987, which we could have guessed something like that happened by looking at the migration history. So that's a very important thing for us to know. Okay? Yeah. We also have the good fortune of having a geology layer here. Show that to you. This is a superficial geology that was mapped by the Department of Water Resources. The purple is alluvial deposits, and which doesn't surprise us, but I do have some questions about the extent to which it's mapped. Now, I won't be using this layer for calibration, but I wanted to make you aware that it was here. You may be wanting to return to it from time to time as you calibrate and as you look at your migration history. In some calibrations, you can actually start with such a geologic layer and work from there. But I'm going to let that rest for a future tutorial. In a similar vein, we have a vegetation layer here. I'm not going to explain the various types of vegetation, but the vegetation was mapped. I won't be using this for calibration either, so I'm going to skip over it. I just wanted to make you aware that it exists. Okay, now if you'll remember on our list, the sixth thing was flow record, and as I said before, a dam was installed. It was actually installed in 1945, and the flow changed. So a major flow regime change like that, we probably shouldn't go before that flow regime change in order to begin our calibration. Okay, I've gone through these things very quickly, mostly to make you aware of the kind of thing that can be important to you. What I found is that I return to these layers, to this information about the history of the channel and the geologic and vegetation circumstances of the channel again and again and again as I calibrate. I keep opening them up. And even as I am done calibrating and I do the forward forecasting with my model, I find myself coming back and look at these because you always seem to have questions on why things behave the way they do. And these pieces of information are really the first place to turn to. So sometimes you notice something, and every time you come back to these layers, you notice something you didn't notice before. But we are going to move on with our tutorial, okay? Where does this leave us? Well, we want to pick 2 years for calibration, a beginning year and a target year. Let me talk about the Meander Migration Model itself for a moment here. Not just the software, but the actual program behind it. In its simplest form, the model simulates that the channel moves or migrates the same amount every year. This is not what happens in nature. In nature, higher flows make a channel move more rapidly than lower flows. Because we're using the model and calibrating it, we use a kind of average constant migration rate for all years. What's important to do is use as many years as possible to integrate or average out the effects of all the years. That's why I always try to use 50-year predictions or long time period predictions. Over time, it's more reasonable that the integrated effects of the real-world migration, some years large, some small, some years no migration at all, that their integrated effects in a sum total way will be simulated by using a constant rate in the model for the same time period. That's why it's best to use a large time period like 50 years. Okay, so how about going back 50 years? What are our limitations here? Well, we want to start with 1987 as our target year because the riprap goes in, and after 87 there's no movement. So calibrating would be kind of tough after 87. So let's make our target year 1987. Going backward 50 years takes us 1937, but that's a little too far back. After some experimenting, which is what you'll find yourself doing, trying something, seeing how that works, trying something else, seeing how that works, I chose 1942. It's very close to 1945 when the dam went in, and it gives you 45 years of migration. And you don't want to go too far before the dam went in, because the flow regime changes, but 3 years, not a big deal. In fact, I actually tried calibrating using 1952, and then calibrating using 1942, and 52 wasn't any better than starting in 42. So 1942 is what I chose as the beginning time period. So there we have it. We are bringing to a close the tutorial on choosing center lines for calibration. It's really important to know the history of your reach in order to choose appropriate center lines for calibrating. Every modeling experience will be a bit different, so you need to consider as much information as you can get your hands on in order to choose the center lines. You bring it as close to the present as you can for your target center line, and then you go backwards a reasonable length to choose your beginning center line. Okay, we've done this now for this particular reach. We've reached this stage. We've chosen the 2 years. Our next step will be to take these center lines into the model and actually start the calibration process. And that will be the next tutorial. Thank you again for listening. If you have any questions, do contact us.